plastics are one of the most commonly used products that are basically polymeric organic materials with a small amount of fillers, plasticizers and lubricants. Plastics can be made into different shapes by using heat or pressure. Unlike glasses, plastics are solid materials. Plastics have varied properties like toughness, resistance to corrosion, ease of fabrication, and are available in various exciting colors. Because of such properties, plastics are widely used for various purposes. The organic material of plastics is called resins. I'm sure you must have heard of resins before. Now, resins are of two types, natural and synthetic. Natural resins include rosin, shellac lignin, viscose, cellulose nitrate, casein formaldehyde, soybean protein formaldehyde, etc. However, synthetic resins are again of two types based on their process of polymerization. 1. Resins of addition polymerization, and 2. Resins of condensation polymerization. So, let us see what these two types of resins mean. In the first type, as the name suggests, there is some addition that happens. A large number of monomers are added to produce a long chain polymer. Now, such chains are folded into a three-dimensional structure to form a bulk material called resin. So, you saw how resins of addition polymerization are prepared. Now, let us also understand about resins of condensation polymerization. Again, as its name suggests, resins undergo condensation polymerization to form a structure. In this process, two or more monomers join together after elimination of simple molecules such as H2O, NH3, alcohol, etc. You must have read about polypeptides before in earlier lessons. Those are formed from amino acids by condensation polymerization. Now, a small amount of fillers, plasticizers and lubricants are applied to these polymerized materials to form plastic. Plastics have various domestic and industrial uses. Polyethylenes of low and high densities are used to prepare milk cartons, carry bags, raincoats, etc. Polyester is used to make insulation, combs, ceiling tiles, television, refrigerator lining, etc. Polyvinyl chlorides are used for making pipes, wires, gramophone records, floor coverings, etc. Similarly, polyesters are used for making films, recording tapes, packing and fibers for textiles. Another material called nylon 6.6 is used for making brushes, bristles, carpets and hosiery. So, now you learnt about various usages of plastics also. I am sure now you have understood the importance of all these industrial products. The role of chemistry in industries is of vital importance. Let's move on to our next product, that is adhesives. Adhesives are commonly used, and I am sure every one of us must have used adhesives at one time or another. You must use glue to paste pictures on the wall at home, to bind covers on your notebook, or to fix a broken frame, isn't it? So, to define adhesives, I would say these are substances capable of holding materials together by surface attachment. And there are basically two types of adhesives. One is a natural and the other is a synthetic one. Natural adhesives, as the name suggests, are found naturally. Some examples of natural adhesive are gum arabica, shellac, animal glue made from bones of animals, protein adhesives made from milk protein, vegetable proteins, egg and blood albumin, and adhesives made from starch and albumin, etc. On the other hand, resins such as epoxy resins, silicones, polyvinyls, polysterenes, and polyamides are a few examples of synthetic adhesives. Some adhesives are also made from different derivatives of cellulose such as cellulose acetate, cellulose nitrate, ethyl cellulose, etc. Some inorganic adhesives also include glasses, ceramics and sodium silicate for high temperature applications. Adhesives are also mixed with plasticizers, wetting agents, etc. You will find different kinds of adhesives in the market, and usually such commercial adhesives usually contain a mixture of 2 or more adhesives. While natural adhesives are cheap, water soluble and mostly used for paper, synthetic adhesives are expensive, water resistant and used for woodwork, plywood and lamination purposes. Let me now quickly tell you about one more important product, that is man-made fibers. The clothes that we wear are made of fibers processed in textile industries. Originally, all these were natural. However, increase in population increased the demand for clothes, and therefore man started making artificial fibers. These are called man-made fibers. The artificial or man-made fibers are more durable, economical and are usually produced in large scale, whereas natural fibers contain cellulose content, that is, polyglucose. Man-made fibers are derived from synthetic polymers. Do you remember we discussed about resin manufacturing by addition and condensation polymerizations? Even fibers are manufactured using a similar process. The resinous materials produced through polymerization are widely used for manufacture of fibers. However, the polymers used for preparing fibers are of specific types and must meet certain important criteria. Let me tell you now about those specifications required for polymers to make fibers. First, the polymers used must have high tensile strength. That means they should not break easily. Secondly, the polymer should be able to withstand the pressure of ironing and washing. They should also resist hydrolysis due to bases present in water. Polymers should also be able to resist chemicals used for dyeing clothes. Similarly, they should also withstand the effects of dry cleaning solvents. Finally, they should also be resistant to sunlight, heat and air oxidation. All these properties make the polymer suitable for manufacture of fibers. There are various ways of making fibers, but most importantly, melt spinning and dry spinning are the most common methods used to prepare fibers. In melt spinning process, the molten polymer is pumped through a porous net called spinneret jet and then allowed to cool to give fibers. Mostly, nylon and rayon fibers are examples of this process. Unlike this method, in dry spinning, the polymer solution is in a low boiling solvent is pumped through a spinneret. Then the solvent is evaporated by hot air outside the spinneret, leaving the polymer fiber. This method is mostly used for cellulose acetate and Orlon.